So, just a second. Yeah, so good morning, everyone who is attending lecture today on distributed software systems architecture. This is our last lecture in this course, and during this lecture we would discuss the rest of the peer-to-peer systems. We would discuss examples of such systems, how they work, and pros and cons of peer-to-peer systems implementation. So, as usual, before the lecture, I would ask everyone to pass the test. So the test is now open. You have 15 minutes, but there are only 2 questions there. So if you would be faster, that would be great. Thank you very much, and let's proceed to the test.
Initializing startup sequence. Loading. 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 All systems will go. Please enjoy your stay. All systems will go. Please enjoy your stay. All systems will go. Please enjoy your stay. All systems will go. Please enjoy your stay.
So less than 2 minutes left. Please submit your answers. So the test is finished now, and I want to congratulate Mohamed Turkif Khan and Al-Fanani Haider Jabbar Swadi that you got 10 out of 10. That's great. You was 100% correct on the test. That's great results. Thank you very much. So let's go to the lecture. And today we would finish a discussion about peer-to-peer systems. On our previous lectures, we covered the basics of peer-to-peer systems architecture and the main protocols that help you to organize the peer-to-peer system. Most of those protocols define the process of obtaining and searching for resources in peer-to-peer systems. So today we would discuss examples of usage of peer-to-peer systems technologies. And we would discuss what systems that are called usually peer-to-peer are not very peer-to-peer, and vice versa. And also we would discuss pros and cons of peer-to-peer technologies. So let's go to the presentation and discuss the usage of peer-to-peer technology. So if we cover the main utilization mechanisms, what applications are using peer-to-peer technology to provide their services, we would be able to identify at least 3 types of applications that benefit from these technologies. First approach, it is distributed calculations approach and computation approach. When you break one big task into a large number of independent subtasks, and you distribute these subtasks between your peers, that is how you can use resources of others to help you to calculate your own problem. The second type of the peer-to-peer systems usage, it is file sharing networks. And this is one of the most common way to use peer-to-peer systems. As you remember from our discussion about the peer-to-peer protocols, file sharing it is mostly efficiently, very, very efficiently can be organized using the peer-to-peer approach. Comparing to the client server, peer-to-peer file sharing benefits from big amounts of users. So the bigger your audience in the network, the faster you can provide your file sharing services. That is why file sharing networks are in the top of the peer-to-peer usage. And of course, we also can use peer-to-peer technologies in our collaboration apps. That is peer-to-peer chat applications or peer-to-peer web conferencing applications. We would discuss the Skype as an example of such system because it was peer-to-peer system before Microsoft acquired it. Now it is cloud-based system, and its architecture and protocol differs from what it was from the very beginning, but we would discuss the history of Skype. So let's start from the first application, distributed calculations. And when you search in the internet for peer-to-peer computing, you would certainly find the BOINC, B-O-I-N-C project. BOINC stands for Berkeley Open Infrastructure for Network Computing. It is a non-profit cross-platform software for distributed computing systems. And you may know it for such famous projects like SETI at Home, the project that was live for more than 15 years searching for extraterrestrial life. And it was closed several months ago, and they did not find anything, but it was very, very famous. But when we would discuss how it is organized, we would understand that this is not peer-to-peer project. It is just very, very sophisticated client-server technology. So BOINC by itself, it is a server that organized as a set of PHP scenarios for organizing and managing a huge calculation project. This BOINC server implements registration of participants, job allocation, and results gathering. So if you would like to organize your massive online calculation, you can take this BOINC server, install it on your machine, and give this server terabytes of data to process. It would not process it by itself. It would distribute your data into smaller chunks and distribute these chunks between the users all over the world. Each user would get his own small chunk of data that it can process, and after processing, it would send you results of the processing back. So on the server, you would be able to get all the results and integrate them. To participate in the BOINC computing process, each client needs a BOINC client. BOINC client is a custom application that allows you to participate in one or more BOINC projects. It is an executable file that you can install on your machine, and when your machine is idle, when you do not use it, it would launch this BOINC client. This BOINC client would connect to the server, take a bunch of data, and process it locally. What are most popular projects on these platforms? So, as I told you, this platform is oriented on huge, massive online calculations. So if the project is integrated in this platform, it should be able to be distributed between huge amount of users. So SETI at Home, analysis of radio signals from the radio telescope to search for alien civilization. That was the first project that started this platform. Other projects like Einstein at Home to test hypotheses for gravitational waves, climate prediction, World Community Grid, malaria control project, simulation of protein structures, LHC at home to help the CERN to calculate for their Large Hadron Collider. So you can install these clients and you can use the power of your computer to help people all over the world solve very, very resource demanding projects. On this slide, you see the user interface for the Boeing platform with its example project SETI at home. So when you install this client on your machine, when your machine is idle, you would see this. You would see how it gets the data from the radio telescope, analyzes it using fast Fourier transformation, tries to identify any patterns in these signals to identify some points of interest in the night sky. So what is the architecture of the Boeing platform? As I said, you have huge amounts of data that you need to split into very, very small chunks that could be processed independently. Each of these chunks is stored on the database that allows you to distribute in this data server that works as a mediator between the huge data that you gathered and millions of users that would like to process this data. When user arrives to the network, he or she asks data server to give it a chunk of data. The server provides the data to the user, and user starts to process the data. If we would have 1 or 2 users, that would not be very sufficient, because why you would organize all this infrastructure for such a low power? But this infrastructure works very well when you have millions of users. Then all of them together, they are organized as a most powerful supercomputer in the world, with a huge amount of resources that could be used to solve very interesting tasks. Of course, there are more to discuss here in the Boeing platform. For example, there are some users that do not want to process data according to the functionality that the server demands. There are some users, they are cheaters. They would like to get all the fame like the users who process most of the data, but in reality, they do not process it. They just get this data, wait for a small amount of time, and send back fake results. They can be randomized, or they can send the same results for each of the data processing that they get. So how can you deal with these cheaters? So with this huge amount of power, you easily can distribute one piece of data between 3 or 4 or 5 independent users. So you give one chunk of data to 5 independent users and ask them to calculate this data. And afterwards, you compare the results. And if all the results are the same, that means that everyone was a real user and they processed this data correctly. But if one of them or 2 of them provided different results, that means that they are cheaters and their results cannot be trusted. These users would be banned from the system. So that is only one example of how this platform is utilized. But you can see from this diagram that this is not peer-to-peer platform at all. Because if we organize these calculations as peer-to-peer, then the users would be clients and the servers. So 2.4 million users in peer-to-peer network, they would communicate with each other to organize this communication. Instead, in this case, they all communicate only with the server. They get the data from the server, they send the data processing back to the server. So in reality, this is not a peer-to-peer system. This is just very highly scalable and decentralized computational platform. But this is truly client-server technology. Next, what I would like to discuss with you, it is file sharing networks. File sharing was the first case of the usage of peer-to-peer systems, and till this day, it is most common way to utilize this approach. Today, there is a large number of peer-to-peer networks that are focused on sharing files between users. There's networks, they can be organized as worldwide networks, including millions and billions of nodes that share files between them. And they also can be organized as a local network in some local communities, networks that allow directly connect one user to another user and share the data between each other. So if we take a look on the landscape, we would say that there are three types of file sharing networks that we can highlight. First type, it is highly centralized file sharing networks. Examples of these networks are such networks as Napster, that was in the beginning of peer-to-peer systems, Kazaa, that was famous in the early 2000s. But now these networks were reorganized because of the legal issues with the content distribution. A lot of file sharing networks, they deal with legally non-legal content. That is content that is defended by the copyright law, that can be obtained non-legally. And if we are dealing with such content and you organize your system as a highly centralized system with central index, then your network would be very, very vulnerable for the legal and network closure. So in this case, these networks are reorganized. Of course, if you share only legal content, for example, if you are sharing open source, or if you are sharing the source code, if you distribute binary file for some game that you are the distributor and you would like to increase the quality of this file distribution, you can use peer-to-peer networks. And a lot of software developers today, they use this approach to organize effective way to distribute their files between the users. It is much more effective comparing to the centralized server client downloading. Second type of file sharing networks, they are partially decentralized networks. And that means that we do not have, in this case, one central index server. In this case, we have one index server, and we had a lot of clients who connected to this index server to get the metadata about what they want to download from the network. And in this case, partially decentralized networks, it works a little bit different. In this case, we have index number 1, we have index number 2, we have index number 3, and they are all deployed independently. So the users in these networks, they can connect to different index servers to search for the data that they would like to download. And if one of the servers is lost due to some problems, that's not a problem for the network, because then clients can connect to another index servers instead. And this index server would also provide them capability to search for the files and to search for the clients who have the same files that they want to download. Examples of such networks are such networks as eDonkey and BitTorrent. And they are today the biggest peer-to-peer networks in the world. The third way to organize this it is without any usage of index servers. And these are decentralized networks. There are no dedicated servers with index. And we discussed previously at least 2 ways to organize the search in such networks without centralized index. These are key-based routing mechanism and broadcast requests mechanism for search. So in this case, the network itself works as a huge index where you can distribute the information between the users of this network about what is the file I'm searching for. And if you use, for example, key-based routing mechanism, you can use the search network overlay to find the file that you are looking for in the network, as we discussed this in our previous lecture. Examples of such networks, it is Gnutella, and also we would discuss the overlay over the BitTorrent network that also works without the centralized index mechanism. So, as an example, and one of the most famous systems for the file sharing, we would discuss the BitTorrent protocol. BitTorrent, it was developed in 2001 by Bram Cohen, and the first client of this protocol, he wrote this client using the Python language. When you would like to download something from the BitTorrent network, you need to obtain the torrent file. The torrent file, it is a special file that identifies the document or the folder or the set of documents that you would like to download from other clients. In this file, you would get the following information. First, you would get information of the tracker. The tracker, it is the index server that we discussed previously. The index server obtains the information about each of the clients that downloads or have the file that you would like to get currently. And the tracker allows you to communicate between the peers. After you get the tracker URL, you connect to this URL, you send the tracker information, what files you would like to obtain from other peers. And the tracker gives you the URL, the identifiers of the users, of the peers that have this file. Also, in this torrent file, you get the hash sums for the segments of the files. So when you download the files from other users, you able to check if the file that, or the piece that you download, it is correct. So commonly the process of working with the tracker works like this. We have the tracker here, the tracker URL, and we have two peers that would like to exchange some files. So this peer, number one, it got this metadata file that is the torrent file. And in this torrent file, it got the URL for the tracker. So using this tracker URL, we connect to the tracker and send the request. I would like to download some files. And in this request, we send the tracker information about the files that we would like to download. The tracker search in its local index where are the peers that have this file. And when it found the peer, it have this that have this file, it sends back to the peer that requested this information IP address of the peer. Using this IP address, the peer directly connects to the other peer that have this file and asks for this file or parts of this file. So after this request, the file is downloaded to the thirst client. After the file is downloaded, we use the hash sum to check if the file that we downloaded, it is a correct file. And after we check that this file is correct, we can be sure that we downloaded the file that we wanted. That is how the connection in the tracker works. Also, here in this torrent file, we can have a set of alternative sources, URLs of other trackers. For example, if this tracker is not working, it is blocked or somehow not available right now, we can connect to another tracker that would also provide us the information about the file and other clients that are listed in this tracker. Of course, in this case, most commonly we have not one user that downloaded the file, but hundreds of users that have the same file, and you can simultaneously download this file from hundreds of different sources. Okay, I'm clear the slide right now. Yes, here we see, okay, on this slide we have the process that I described on my previous slide. Another feature that I need to highlight here, it is the specific way how the first how the file is integrated to the network when there are no such file was in the network previously. So let's imagine that we have some very new file, for example, a new version of Ubuntu distribution. And this is a big file, like several gigabytes. And we would like to make this file to the peer-to-peer network as fast as possible. Then the server that has the copy of this file, this is the server that has the only copy of this file on the first step, enters the so-called supersede mode. In this supersede mode, the server tries to distribute this file between using very, very small chunks. You can see here, these are very, very small chunks of this file. And the supersede tries to distribute these chunks evenly between the nodes of the network. So you can see that on the first step, the supersede sent the data to this node and to this node. On the second step, the supersede sent another pieces of data to this node and to this node. And on the last step, the supersede sent the final pieces of data to, let's go check, to this node and to this node. And that means that in 3 steps, the supersede specifically distributed pieces of data between the nodes on the web, not on one server to have all the copies on one server, but instead it distributed the pieces of the file evenly between all the nodes in the network. Because if it distributes the pieces between all the nodes, then afterwards all the nodes can in parallel connect to each other and use all the capacity of the network to share the pieces between each other on their own. That would allow to generate the most of the network, to use the most of the network capacity to create the most amount of copies of the seeded file and to increase the quality of the peer-to-peer network. Another thing that I wanted to discuss with you today, that is the overlay network for the BitTorrent protocol, or the network that allow you to use BitTorrent protocol as a system without the centralized tracker. As you remember here, I told you that there are partially centralized network like BitTorrent, and we also have the decentralized network that allow you to search for resources without the need of the centralized trackers. So the distributed hash table, or DHT approach, allow you to use the BitTorrent protocol without the need of centralized tracker. This approach is based on the key-based routing mechanism that we discussed in our previous lecture. That mechanism is based on the concept that when you add a new document to your network, you assign it a special key, and this key allows you to route this document through the network. So a copy of this document or a reference to this document would be stored in huge amount of nodes between the network. And if you would like to find the resource in this network, you just submit the request with the key for the resource that you would like to find, and using special algorithms for this key distribution, you would find the reference to this document using the network itself without need for the centralized tracker. So in the case of BitTorrent network and the distributed hash table mechanism, this approach is implemented using the calculation of the Hamming distance between the nodes' IDs. And instead of the torrent file that you gather from the torrent server and that you use to connect to the tracker to search for the file, in the DHT approach, you get a thing that called a magnet link. A magnet link, it is just a very, very long ID. This ID identifies the document that you try to find. And when you go to the network and you get this ID, you start to communicate with your neighbors, with the list of the neighbors that are nearby, and you start to propagate this document between them, asking them if where do I go to find this document. And in the end, this mechanism allows you to find peers that would have this resource using the key routing mechanism. Of course, this approach needs you to get this key. Without this magnet link, you would not find anything in this distributed hash table network. But this, a lot of people, they call this a future for the distributed network, because it allows you to find information without the need of centralized trackers or servers. If you have on your machine a BitTorrent client, and you would go to the temporary folder of this BitTorrent client, you would be astonished, because you would find there at least several hundreds megabytes of these parts of the files that you would be able to search using the magnet links, because almost all current BitTorrent clients are participating in this DHT network. So, last type of applications that we would discuss today, these are collaboration applications. And these collaboration applications allow geographically distributed users to communicate, collaborate, share files, use like chat or video calls applications. So examples of such applications that use peer-to-peer technologies, it is Skype that we will discuss today, and BitTorrent Sync or Resilio Sync that allow you to use peer-to-peer systems to synchronize and archive your own files. So Skype, it is one of the most popular voice over IP systems today, and it was originally developed as a decentralized peer-to-peer system. As I told you before, when the Microsoft took them and when they bought them, they redesigned the Skype architecture to work with their Microsoft Cloud Azure services. But originally, Skype was designed as a peer-to-peer system. And there were three main types of nodes in Skype. Skype login server, that was the centralized index for the search and metadata, as we discussed. Skype client node, that was the final, the node that was installed on your machine and that acted as a way to organize communication, video calls or chat. And there were some supernodes. A supernode was a specific type of node that worked as a router in the system. So if some node was behind some net or firewall, the supernode would allow to organize the communication with this node. Also, they had some special nodes for establishing communication with fixed telephone lines, because using Skype you are able to call like a mobile phone, cell phone, or a stationary phone in the local phone. On this picture you can see how the communication between the Skype nodes was organized. So if we have a company network and we have 2 users of Skype inside this local network, then these 2 users, when they would communicate with each other, their communication would not go anywhere, but it would stay inside the company network. So everything that they share, everything that the voice call they organize, for example, it would be stayed inside the network and it would not go to the internet. But of course, before they can start communicating, they both need to connect to the Skype network, to the index, send the information that they're in this network, they have this IP address, and afterwards they can communicate with each other. To connect to all other users using the internet, if they're both located over the firewall, they can connect to the supernodes. And there were cases when my friends, they was very frightened because Skype decided that their computer and their network connection is good enough. So when they install Skype on their machine, it starts working as the supernode and it starts sharing the network capabilities to organize the communication for the users who are inside the network, who are inside after the firewall, behind the firewall. So just imagine you open the Skype, you do nothing, but the Skype starts to connect to other nodes. It starts get a lot of requests and it starts send some data to other nodes. It looks like it is some kind of malware or some kind of virus that got your system, but in reality it is just the Skype network decided that you are very good and your connection is very good, and we would use your node as a supernode in the network. Other application that I would like to tell you today about, it is Resilio Sync, or previously BitTorrent Sync. Resilio Sync, it is a system for secure file synchronization between your devices using BitTorrent protocol. So I think you all know about such systems as Dropbox or Microsoft Live Drive or Google Drive. How this system works: you have your drive, let's just some kind of cloud drive, and this drive is located in the cloud. And using different systems, they would like you to pay them for the amount of data that they would allow you to store in this drive. So you pay them money to store your data, and of course they have all the necessary access to your data that is stored in the storage, on their storage. So you have like mobile application, you have a laptop here, you have a desktop here, you have your work computer here, and all of these machines, they are connected to this drive that is located in the cloud. And when you change something on your work machine, for example, these changes are synchronized to the cloud, and after the synchronization is processed, these changes would be synchronized to all the clients on your machines. That is how the client storage works today, independent on what provider do you have. Google Drive, Microsoft Live Drive, OneDrive, I think, Dropbox, or any other solution. And that's great, but let's imagine that you have not like 5 gigabytes of data, but you have 50 gigabytes of data that you would like to share between your nodes. And if you go to the prices, for example, for the Dropbox, to share 50 gigabytes of data, you need to pay them. How much you need to pay them? Actually, Dropbox price. So, okay. So to get you possibility to share 2 terabytes of data. Okay, but free, you have possibility to share only 2 gigabytes for free in Dropbox. 2 gigabytes. If you have more than 2 gigabytes, you need to pay them $10 per month. $10 per month to share almost like more than 2 terabytes of data. But if you have no 2 terabytes, if you have just to share 50 gigabytes, you also need to pay them $10 per month. That is not good. $10 per month. Why do I pay them so much? So in this case, you can use Resilio Sync. Resilio Sync works like this. Let's imagine you have the same machines. You have your mobile phone, you have your laptop, you have your PC, and you have your work PC. And you have 50 gigabytes of data that you would like to share. If you install Resilio Sync on each of these machines, you can add your folder with the files, and when your machines are online, they would automatically synchronize their state between each other. So if you're able, for example, to have your machine working every day and every night, or you can just work machine, it is like always on, then you would be able to synchronize the data between these machines without need of the cloud storage at all. You do not share your data with the cloud provider. You do not pay them money to store your data. All your data belongs only to you and shared between only your nodes. Of course, Resilio Sync allows you to create some share folders that you can send a link to other user and say, okay, if you would like to get this data, I give you the link, and the user using Resilio Sync can connect to your data and download it if you would like to share some data with some other users. So Resilio Sync works on most modern operation systems, on macOS, on Windows, on Linux, on FreeBSD, on Android. it also works very good on Raspberry Pi. So if you would like, you can create your own microcloud server with Resilio Sync launching and working on the Raspberry Pi constantly and working as a file server for all your data. If you connect to this Raspberry Pi your like 1 terabyte drive using USB or network connection, you can use Raspberry Pi as your own cloud data storage. So Resilio Sync interface looks like this. You create folders on your machine and you say the Resilio Sync to synchronize these folders between your machines. It can use different ways to organize the communication between the machines and search for the resources using local peers discovery, peers exchange. It can save the information about known hosts. It also can use distributed hash table to find the nodes that are yours and to distribute the data between them. Of course, these are not the final and whole list of all applications of the peer-to-peer systems. There are a lot of other applications known. For example, such applications as Bitcoin approach, overlay networks for anonymous internet access, IPFS file system, like it is a content-addressed peer-to-peer hypermedia communication protocol. So peer-to-peer approach today, it is very, very commonly used for data exchange, and you need to know about the peer-to-peer if you'd like to work with distributed systems. So some final thoughts about peer-to-peer approach. What are the pros and what are the cons of peer-to-peer? First of all, when you combine different types of resources, of course, peer-to-peer concept allows you to organize universal access to resources in highly heterogeneous computing environments. But you need to know that each of the nodes in peer-to-peer network has its own individual specifications that may limit its role in the peer-to-peer network. For example, if the node is located behind the firewall or behind the net, it is not as easily reachable as the node that has its own public IP. So when one develops the protocol for the peer-to-peer network, he or she need to always take in mind, always take into the account that some nodes would not be easily reachable. So you need to have some specific types of nodes to organize this routing between them. Peer-to-peer is all about direct end-user communication and interaction. But it cannot provide you the guaranteed quality of resources and quality of service, because each of the users, each of the peers has its own network, has its own limits on the network speed, network capacity. Some of them use high speed fiber optics, others use dial-up connections and LANs or corporate networks that are hidden behind the firewalls. So you cannot guarantee the quality of peer-to-peer communication between each of the users. You need to do something with this. Also, there are a lot of security issues. When you are developing your client-server application, you are the only owner of the server, and you can guarantee that the server, it is your responsibility. And when the client sends information to the server, you know that that is the owner of the server that you send this information, and this owner is responsible about what he or she will do with this information. In the case of peer-to-peer systems, each of the peers is owned by its own user, its own owner. So there could be some kind of cheaters. There could be some kind of false users that would not provide you the quality of service that you need. There was some specific type of attack on peer-to-peer networks in the early 2000s when lawyers wanted to close some peer-to-peer networks. They started to advertise false files. So the name of the file was like very, very famous song, and it was just very, very famous song.mp3, and this file was shared between hundreds of false users. And when the real user wanted to download this file, it found, okay, these are the users who have this famous song, I would download this song from them. But instead of this song, they downloaded some garbage. So in peer-to-peer network, there is no simple solution how to deal with these cheaters, how to deal with the users who do not play the game and who do not act in the correspondence of the protocol of the peer-to-peer system. Of course, lastly, peer-to-peer systems are targeted at a large number of connected nodes. So if you plan to develop peer-to-peer system protocol, you need to understand how to deal with scalability, how to deal with the hundreds and thousands of connected nodes that could be inside your peer-to-peer network. In the client-server technology, we have some standard ways to organize this. You can start scale your system. You can add more servers to deal with the new arrived users. How to deal with this issue in the peer-to-peer network, it is very, very different approaches. So that is the end of the discussion about the peer-to-peer networks. And I would like to say thank you very much for participation in my course on distributed software systems architecture. And I hope that you find this course interesting and useful for the development of your future distributed systems. In the next semester, we would proceed with the distributed systems topic in the cloud computing course. So thank you very much for participation. And as always, after the lecture, I would like to ask you to pass a simple test that would highlight that you was in the lecture. Oh, by the way, next week we would have a formal graduation in this course and formal final assignments. And as I see, almost everyone have the mark that it is that you passed this course. Everyone who go to the their online journal and check, if you have more than 60% of the ranking, you passed the course. And that means that There is nothing new to worry about. You just need to participate in the final meeting, where I would officially highlight all the persons who passed this course. There is only one person in this course that did not pass it, because he did not submit any labs, and he did not attend it on the practices that were specifically designed for him. So on this, I would finish my lecture, and I would give you the link to the final questionnaire. Thank you very much for participation, and have a very, very good day. See you.